Temperature and solubility of solids. Increased temperature usually increases the solubility of solids in liquids. According to the second law of thermodynamics, increased temperature means a greater average velocity for the particles, right? Particles, as we add heat to them, right, they start to move even more rapidly. We talked about this in the previous lecture. This allows them to move from one position to another more easily. The greater the freedom of movement allows a system to change its state more easily, right? So we're changing from solid to a liquid to a gas. What do? We need to increase the temperature. We increase the temperature, we increase the kinetic energy, we allow more energy there to these particles. These particles now have no choice but to bump away from one another and actually make their way, and break away from their state of matter, whatever they're in, solid to liquid to gas. Now, the change in solubility with change in temperature can be used to create solutions with more solute dissolved than is predicted by the solubility of the substance. So, here we have the following. Notice here as the temperature increases from 25 degrees as our lowest to 90 degrees Celsius. So what we have here is the solubility in grams of glucose per 100 milliliters of water. So here, we have 91 grams of glucose can dissolve in 100 milliliters of water, right? And as we increase the temperature from 25 degrees to 90 degrees, look at the amount that we can actually dissolve. 556 grams of glucose can dissolve within 100 milliliters of water. So notice, temperature is increasing, more solute can dissolve. So, if we add 100 grams of glucose to 100 milliliters of water at 25 degrees Celsius, only 91 grams, only 91 grams will actually dissolve in water. The remaining 9 grams, is going to remain at the bottom, and the solution is saturated at this temperature. So, the solvent is holding the maximum amount that it can have had dissolved within it. The maximum amount, 91. Which means we've got an excess of 9 grams. Right? If I want to dissolve those 9 grams, what do I need to do? I need to increase the temperature. Right? Because I need 9 more grams, let's say, to dissolve. But I've already fulfilled my maximum. So it's a saturated solution. I've dissolved the maximum amount that I possibly can. If we heat the mixture up to 50 degrees Celsius, the remaining 9 grams of glucose will dissolve. And at the new temperature, the solubility limit in 100 milliliters of water is 246 grams. With only 100 grams of glucose dissolved, our system is now considered unsaturated. Now, we went from saturated to unsaturated. Why? Well, we've increased the temperature to 50 degrees Celsius. At 50 degrees Celsius, we can dissolve up to 244, but we've only put in 100 grams. We put in 100 grams at 25 degrees Celsius, we only dissolved 91 grams. We increased the temperature to 50, it dissolved the remaining 9 grams, which now I have room to dissolve even more sugar, more glucose in that solution, right? Because, well, I've got room for it. Because I have room for it, that's what makes it unsaturated. So if I have an unsaturated solution, I have more room to dissolve more solute. If we slowly cool the mixture back to 25 degrees Celsius, 9 grams of glucose should precipitate from solution. Sometimes this happens immediately, but sometimes it takes a while for the glucose molecules to find their positions in a solid structure. So what we have here is, well, we tried to dissolve 100 grams. We did it in the 100 milliliters. But we had to raise the temperature above 25 degrees Celsius. But if we cool it back down, right, we've dissolved 100 because we've raised the temperature to 50 degrees Celsius. But we've lowered it back to 25. At 25, I was only allowed to dissolve 91 grams, which means the remaining 9 grams is actually going to precipitate. It's going to be the last little bit of solute that was not able to dissolve in my solution. Okay. So in the time between the cooling of the solution and the formation of glucose crystals, the system has a higher amount of dissolved glucose, 100 grams, than is predicted by the solubility limit of 25 degrees Celsius, which is at 91 grams. Because the solubility, or because the solution contains more dissolved solute than is predicted by the solubility limit, this is when we call a supersaturated solution. Because even though we've lowered the temperature, it still has more solute than it can hold. And until that, finally kind of, gets back, right? Remember, the solid is not just going to clump together and start to form. Right? So because it hasn't done that, it's considered supersaturated, right? Imagine, it's anything that's supersaturated, it's got more, right? Saturated means it's got the most amount that it possibly can hold. That's allowed to be held, scientifically. But then we have supersaturated, which means it holds even more than theoretically it can hold. Okay, so here we have, so we've got in the 100 milliliters, 100 grams in the 100 milliliters of water. So at 25 degrees, we've reached something called a dynamic equilibrium. Equilibrium meaning we're holding the most amount, right? It's equal and it's not going to change. This remaining 9 grams is going to remain that way. Maybe some might dissolve out while others are going to re-solidify itself. Okay, but it's reached that point where it will remain 91 grams, right, to 9 grams. So 91 grams that is dissolved to 9 grams that is undissolved, right? We're going to add heat to it to the point where we're going to dissolve all 100 grams of the glucose. We're going to cool it down. Okay, we're going to cool it down to 25 degrees. We still have 100 grams. It hasn't precipitated yet. Because it hasn't precipitated, right? It's not just going to do it magically, right? We've lowered the temperature, bam. There, we know where it's going to bring. Eventually, over time, right? The 9 grams that is still left over is going to precipitate itself. But before that, we reach something called supersaturation. We've got more solute that we technically should be able to dissolve. But as time goes on, right, the particles are going to kind of solidify and we will reach that dynamic equilibrium, which is considered a saturated solution where only 91 grams will be dissolved, which will allow the 9 grams to precipitate back because we can't dissolve more than 91 grams at 25 degrees Celsius.